Assalamualaikum and good morning to Dr. Nashirin. My name is Muhammad Syamil bin Abdul Majid. My metric number is 185162. Okay, for my assignment, I would like to choose about a DC chopper in controlling the speed of the electric vehicle. So why I choose this topic? Because this DC chopper is already mentioned in the past, present and future of power electronic by Bimal K. Boss. So I choose DC chopper because it's already mentioned in this the DC chopper for a DC motor drive in the electric vehicle. So I will choose this part to explain further. So how DC chopper control the speed of the DC motor. So for introduction, the chopper is a static device that converts a fixed DC input to a variable DC output voltage directly, which is we give the input like a 5 volt, we can change the input to a 10 volt, 12 volt or less than 5 volt like a 2 volt. Is based on the type of the chopper. So a chopper is considered as a DC equivalent of an AC transformer since it behaves in an identical manner. So in AC, we also can produce the output voltage higher or lower, same like a chopper, but the AC transformer is for AC source, DC chopper is for DC source. So the chopper also used in trolley car, marine horse, forklift truck and mine hauler. So the future electric automobile are likely to use chopper for their speed control and braking. So for this part, I would like to explain further because we use a chopper in controlling the speed of the electric vehicle. Why we use chopper? Because the chopper offers smooth control, high efficiency, fast response and regeneration. So this is a picture about our DC to DC converter, which is the input is a DC and the output is a variable voltage, which is we can change the input voltage. So how did DC chopper contribute to my life? So at my university, we use an electric car. So how we control the speed of the DC motor? We use the DC chopper. So the speed of the DC motor can be controlled using armature voltage control, fixed flux control and armature resistance control. In our electric vehicle, we use armature voltage control, which is we control the voltage based on the DC chopper. So if the voltage of the DC chopper is higher, the speed is increased. It means that the speed is depend on the voltage at the armature. So there are two types of chopper, which is step up. So in step up, the output is higher than input. For this is the circuit for the step up, which is a large conductor L is in series with the source voltage. So during the time period T on, the chopper is on, the inductor store the energy. So the short circuit there. When the chopper is turned off, the current is forced to flow through the diode and load for a time T off, as the inductor current cannot die suddenly. So the voltage V out is the source voltage. So it means that higher than the input voltage. That's all. So for the step down, the output voltage is less than input voltage, which is opposite with the step up voltage. So in this circuit, the thyristor is act as a switch. When a thyristor is on, supply voltage appear across the load. When the thyristor is off, the voltage across the load will be zero. So this is the equation for the step down chopper, which is V are equal to dV, which is Vs is the input and D is the duty cycle. So if you want to increase the output or decrease the output, is more depend on the duty cycle. So the operation of DC motor using a DC chopper. So when chopper is on, motor gets supply, but when chopper is off, motor does not get the supply. So VDC, which is the output, is equal to T on over T on plus T off times V feed, which is this is the period, this is T on time. So the T on over T total is normally called a duty cycle. So the duty cycle is more the average DC voltage supply to the motor is more, and so speed of the motor is increased, which is if the duty cycle is increased, the output of the DC motor is also increased. So normally we can adjust the duty cycle based on the turn on time of the thyristor. So the duty cycle is varies on and off time of chopper. The speed motor can be varied. So this is how we control the speed of the electric car. Then the output of the DC chopper normally feed into the armature voltage, which is the part that not moving in the DC motor. So this is our block diagram for armature voltage control. First, this is a reference speed. For example, we want to set at the 50 millisecond. So this is the PI controller, which is proportional integral. So this is the input. So at the reference we set 50 millisecond, and then the DC chopper input is for example, for the motor normally use a 60 volt. So a DC chopper will increase the input of the DC chopper, for example, from the 60 volt into the 100 volt. So 100 volt is proportional to the specific speed. For example, 70 voltage is equal to 100 millisecond, and then it will display on the current voltage speed. So for the conclusion, this is our example of the electric car. So the speed of the motor can be controlled by changing the voltage at armature winding. So normally we use a DC chopper to control the speed at the armature winding. We also can use a resistor, which is a potentiometer, but if you use a resistor, normally is lot of power loss in the resistor. That's why we use a DC chopper. So the DC chopper have two type, which is step up chopper and step down chopper that I already explained before this. So for the step up, the output is higher than the input. For the step down, the output is lower than the input. We also can have a step up and step down at the same time that we call as buck boost. But the output is normally negative to the input. For example, the input is 10 volt, the output is negative 10 volt, which is opposite to the input. That's all from me. Thank you.